1.1, solve one-step linear equation. Before we get into the equation part of this, it's important to understand some of the terminology here, such as solution. I'll say, what is the solution to this one? Or this is the solution to this equation. Okay? It's important that you understand that a solution is a value that you could replace a letter with that would then make the original equation true. Okay? So when you see something like solve or solve for x, it's really saying what value of x would make this equation a true statement. Okay, so there's a little bit of change in understanding what the question is asking here, but if you can understand it, you'll understand the why we're doing what we're doing, okay? Now, what this also means is that whenever you get to the end of a problem, like, dude, I solved for x, x is 5, all right, you can go back and actually check to make sure that it will be true, okay? And this is really useful because on a test, you could take that x value, go back to the original equation and make sure that it is true. And if you don't do that, I mean, some of you guys like to gamble, which is up to you, but you kind of are gambling with the answers you got, okay? So like this one. Now this is an equation. What makes it an equation? It has an equal sign. If it didn't have an equal sign, it would be considered an expression. Not that I think you care. But x equals 10. Now I could ask, and this one, I'm not trying to make this obvious. I mean, it is obvious. It may be obvious, but the question here, right? What is the solution for this equation? What it's asking is, what value of x would I need to replace x with in order to make this true? It's 10. So if I took the x there and made it 10, boom, it's true. Now, if you didn't know that 10 equals 10, it doesn't mean you're a bad person. It just means that you may need to be in a different math class, okay? But 10 does equal 10. That is a true statement. It's true today. It was true yesterday. It's going to be true tomorrow until I've seen some curriculums that are coming out that say it doesn't matter. But for now, it matters, okay? For now, 10 does equal 10. And you could replace that x with 10, and it would be true. See that? All we're going to do is expand on this, right? So now I got x plus 2 equals 10, right? So x plus 2 equals 10. Well, now, see, look, if I go in here and I say, look, I'm going to replace x with 10 now, it's false. Because 10 plus 2 is 12. That's not true. So I got to go back here and I got to say, well, what value of x would make this true? And you could think for a while if you wanted to or if you needed to. You're going to find the answer to this one is 8. So beneath this, you could write x equals 8. Meaning, if I replace x with the value number 8, I get a true statement on this one. Okay? Or on this one, x minus 3 equals 10. Okay, well, what value of x would I need to replace x with in order to get this to make this a true statement? And again, thinking about this for a little while, you should see that the answer is 13. Because 13 minus 3 is 10. 10 does equal 10. So now I know for sure that x equals 13. This is the solution is x is equal to 13. Because that's the value. 13 is the value you replace x with. What about this one? 2 times something. And this is another way you could look at it. 2 times something equals 10. So what would I have to multiply 2 by to make this equal 10? Well, it'd be 5, right? If I replaced x with 5 here, well, then you'd have 2 times 5 equals 10. And 2 times 5 does equal 10. That's true. Boom, true. So now I know that x equals 5. All right? Now, there's more formal strategies that we'll use to solve these, but for now, this will do. Because some of these you guys may be able to look at and be like, dude, I know how to do that one. I can do it fast. I can do it in my head. Okay, that's fine. Oh, now it's division. This is where I start to lose some students. Like, something divided by 4 equals 10. Okay, well, what is that something? What value of x would I need to make this a true statement? It's 40. Okay, so if I replace the x with 40, I get a true statement. 40 divided by 4 is 10. 10 does equal 10. That's true. So I do know that x equals 40 in this case. All right? So if you can understand that that is what a solution is, a value that you replace a letter with to make it true, hey, like I said, you can go far, man. Now, the formal process we use in mathematics to solve these is called principles of equality. You have to memorize these. No, you do not. Okay? In fact, usually people just say, whatever you do to one side, you got to do to the other side. What that means is you got the equal sign. You got 2 sides of the equal sign. Whatever you do to one side, you got to do the other side, right? So for these, I'll use the addition right there at the top. So let's go back to 10 equals 10, right? We know 10 equals 10. That's pretty good. In fact, I'll give myself some space here to emphasize the point. So 10 equals 10. That's true, and it's true as far as we know. But if I said 10, I'm going to add 5 to that. If I wanted this to remain equal, I'd have to add 5 to the other side. See, I add 5 to one side, I have to add it to the other side. Doesn't matter which one you start with. Can I start with the right side? Yeah, you can. Doesn't matter. And you can do this with all 4 basic operations of math: subtraction, multiplication, or division. You can do it anytime. So if you need to change something on your own, you can do that. You can do that, and it's okay. All right. All right. Now, some of you guys, like I said, you could do this in your head, and that's freaking awesome. But I'm going to use principles of equality to get us rolling on this, because we're going to see bigger problems in the future. Do keep in mind, though, that one-step equations usually only require one principle of equality. So like this one, see how I got k minus 9? What I really want here is just k, right? Like if I can just make this k equal something, it's solved. But right now it's k minus 9. It's that stinking minus 9 that's stopping us from the solution here. So I gotta get rid of that minus 9. What do I mean by get rid of? Well, really what I would like is this to be k minus or plus 0 equals, I don't know what it equals, but something. Now, if I change it like this, I've got to maintain equality. So I don't want to change the value of the full equation here. So I got k minus 9. How do I make minus 9 a plus 0? Well, for me, I'd just say add 9 right there. See that? Well, see how this really is a negative 9 right there. That's a term. And then I added 9 right there. Boom, I got 0. That's exactly what I wanted. But remember, the principles of equality say if I did it to one side, I got to do the other side. So I would need then to add 9 on the right side. Well, then I got 5 plus 9, which then gives me 14. And really, plus 0, we can make that what we call a phantom 0, which is really all we're going to be doing. So we end up with just k equals 14. Okay. Now, that means that if I go back to my original equation, and I'll do this for now, but in the next few problems I probably won't, just for the sake of time. This is the original equation, k minus 9 equals 5. If I want to check for truthfulness, I'm just going to replace that k with the value that I just found, 14. And I will check for truthfulness, so I'm going to put a question mark over the equal sign, because I don't know if it's true or not. I know some of you can do it in your head, and that's fine. But 14 minus 9, boom, it is 5. 5 does equal 5, that's true. So now I know for sure, and this would be nice on a test, because you can actually check to make sure that your answers are correct. Now I know that it's correct. It is the solution to that equation. Solve 19 equals 12 plus x, so principle of equality here. I don't want that plus 12 with the x. I just want x, right? This is what I really want in the end, so I can see my goal here, my destination, if you will. I don't want that plus 12 there, so I need to zero it out. So how am I going to do that? Well, I'm going to subtract it from itself. Right? Now, I put that line through the equal sign so I know where the equal sign is when I'm doing this work. And so I wrote minus 12 on the right, so I know from principles of equality that I got to do it on the left as well. So then I got to do minus 12 right there. Does that give us 0? It sure does. 12 minus 12 is 0. But now I got 19 minus 12, which is 7. Now, some of you guys are like, I don't know what 19 minus 12 is, but I'm too embarrassed to use my calculator. Please don't. The calculators are there to help you, even for minor calculations. Sometimes it's just that we're tired. I don't even know what it is, but that should be true. In fact, let's check. Let's check for truthfulness. I said I wouldn't, but I feel like I should now. 12 plus x, right? 19 equals 12 plus x, but I'm going to replace this x with 7. So here we go. Replace x with 7, and I will check for truthfulness right here. So there's my question mark, because I don't know if it's true or not. But 12 plus 7 does equal 19. Okay. 19, does it equal 19? Well, last time I checked, it's true. So there we go. It's true. X does equal 7. Is it okay that the x is on the right side of the equal sign? Of course it is. It still tells us what value to replace the x with. I showed that work right there. And I do want you to get used to doing it. Okay, because if you don't start now, then it's not likely that you'll do it when the problems are really big. All right, so we just used the addition principle of equality, then the subtraction principle of equality. On this one, that's multiplication right there. For those of you that didn't realize, that's multiplication between the negative 8 and the v. Remember, though, I don't want I don't want a negative v, I just want v on this. I don't even want negative 8 v's. And you can think about expanding the multiplication on this one, which would make this more complicated. But really all I want to do on this one is make this v. Well, the number that's being multiplied by the letter is called a coefficient, okay? You may look at this v right here and be like, dude, there is no coefficient, or it's 0, because that happens often. It's 1. It's a phantom 1. Because sometimes with 1, we don't have to show it. And this is the identity property of multiplication, not that I think you care, but it is, okay? How do I make a negative 8 a 1? I got to force this negative 8 to be a 1, okay? So how am I going to do that? I'm going to divide it by itself. Hey, that's pretty easy right there, right? Negative 8, anything divided by itself is 1. So there's my phantom 1 right there. Now, if you leave it like this, you're going to get it wrong, because whatever you do to one side, you got to do it to the other side. So I got to take the 40 and divide it by negative 8 as well. And I find that v equals negative 5. Now you can check. I'm not going to write the work on this one, but I can check verbally, or I can check on a calculator. I can do negative 8 times negative 5 and see what I get. Boom, 40. And now I know that this is true. You may see problems like this on the homework would say, if your answer is a fraction, then write it as a fraction. No problem, we can do that, okay? And again, if you have the TI-30XS multi-view, it will change your answers into fractions if you need to, or decimals. It can rotate between the two. All you're going to do is right above the enter button on the bottom right. I know some of you guys don't have it yet, but if you have it, there's a double arrow button right above the enter button. It just to alternate between fractions and decimals, okay? So on this one, negative 9 equals negative 9x equals negative 21. Let's look at this one, then we'll consider the answer if it needs to be written as a fraction, right? So I don't want this to be negative 9 times x. I just want this to be, again, that's a phantom 1x. How do I force a negative 9 to be a 1 and not change the value of this thing? I'm going to divide it by itself. Just the coefficient, though. Negative 9 divided by negative 9, it is 1. Now, you may have seen teachers in the past cross this out like I've just done right there. That doesn't mean it cancels out. It means I used a 1. That's a 1 right there. Sometimes it's slanted, by the way. So this one, though, is just straight up and down because it's a 1. Hey, that's the phantom 1 right there. That's what I'm talking about, okay? It's a phantom 1, so we don't actually have to show that. What if you do show it? No problem. I would never mark you points off if you showed that phantom 1. But I just did that to the left side of the equal sign. I got to do it to the right side, okay? So negative 21 divided by negative 9. I'm going to do this by hand because I don't have my calculator with me. 2 negatives makes a positive. Maybe I should do that different, positives. 2 negatives makes a positive. I know that 21 and 9 are both divisible by 3, so 21 divided by 3, that gives me a numerator of 7. 9 divided by 3 is 3. 7/3. Hey, that's good. That's a fraction right there. It's improper, but it's a fraction, and it should work. Now, like I said, you can check this. And so you could go in there and you could say negative 9 times 7/3. What do you get? You'll get 20. You'll get negative 21. And just put that in the calculator. Actually, along those lines, the improper fractions, they're easier to work with. And some of you that may have taken like 900 and 950, you may know that. It's easier to work, mathematically speaking, with improper fractions. Now, like when you go home and you cook, are you going to use 7/3? Probably not. Okay, like you'd use 2 1/3 cups, right? Okay, 2 1/3, that's fine. It'd be weird if you use 7 scoops of 1/3 cup. Although I've done it before because I'm a nerd. This one's kind of deceptive. Like I said, knowing what the coefficient of a letter is in an equation is crucial. And on this one, some students would say there is no coefficient, just like as if it was just an m. There is a coefficient. It's one of those phantom 1s. It's just this time the 1 is negative. We don't have to show it if it's just a 1 like this, okay? Sorry, my handwriting is kind of bad, but that should still work. Okay, so negative 1m equals 15. Remember, though, that we don't want this to be negative 1m. We just want it to be m, or positive 1m. It's a big difference. How do you make anything a 1? Hey, just divide it by itself. So negative 1 divided by negative 1, that's 1. So 15 divided by negative 1, you can put that in the calculator if you need to. It's negative 15, though. Can you check this? Yeah, in your calculator, you got a negative button. It's just one button to the left of the enter button, and you can, I think that's where it is. I'm doubting myself, but thank you. So just push the negative button, and then you push negative 15, and then see what it gives you. It's 15. So we know then that that's true, so I should box that in. All right, here we go. There's some division right there. R divided by negative 6. We've already seen the division principle of equality. How are we going to make this negative divide by negative 6 a 1? Well, if you said multiply, you were correct. And all I'm going to do is show this, make this a little bit bigger. I'm going to say, look, see that divide by 6? This is what we call inverse operations. Again, that's vocabulary you don't have to memorize, but I'm going to multiply by -6 here. Now I cross that out. Does that mean it just cancels away? No, it means that's a 1. It's just slanted. That's a 1. -6, that really becomes -6 divided by -6, which is 1R now. But, well, if you do it to one side, you need to do it to the other side, at least if you want to maintain the equality piece. So here I have -7 times -6. Put that in the calculator, it's positive 42. Done. Oh, I should check, right? So 42 divided by -6, it's -7. I did it. Uh-oh, fractions like this. Oh, man, we see those fractions and we just want to quit. Not today. That's 2/3 x. In fact, this one, it's not really as bad as it looks, even though there is a fraction. What is it we want? We want 1x. Right now we got 2/3 x. Dang it. How do we make a fraction of 1? Well, all we're going to do is divide it by itself. Divide by 2/3. Because anything divided by itself, 1. It's 1. It's just, if you do it to one side, you got to do it the other side. Now I showed the division different. Hopefully that's okay. So I'm going to do 16 divided by 2/3, and this should work. All right? 16 divided by 2/3. You can put that in the calculator. Remember the fraction button I was telling you about? Use it. 16 divided by 2/3, it should give you, let me make sure I'm doing 24. So now that it's been brought up, let's look at that. So some of you guys, maybe you've learned a different strategy. 2/3 x equals 16. And you'd say, I'm just going to multiply by the reciprocal. It's okay. It's multiplying by the reciprocal, that's dividing by fractions, right? Because we don't actually divide by fractions. So some of you guys would be like, I'm going to multiply this by 3 halves, but if I do it to one side, I got to do it the other side, right? Same thing, because the 3's are going to become a 1, and then the 2's are going to become a 1. Those are phantom 1's right there. You get x equals, what do you know, 24. Same answer, just a different strategy, that's all. If you do this by hand, then what you're going to end up doing is you're going to make that 16 over 1 like this. Now, I use cross simplification, and again, would you ever be required to do this? No, I would say put this in the calculator, be done. But if you want to do this by hand, 16 and 2, those are going to simplify. They're both divisible by 2, so 16 divided by 2 is 8. 2 divided by 2 is 1. And now you got fraction multiplication. 8 times 3 is 24 in the numerator. 1 times 1 is 1 in the denominator. Same answer, just shown a little bit differently. I would simplify that just into a straight 24, though.